guys, let's go ahead and start off this tutorial by looking at some of the truth tables for some of the operators right here. So we have the not, we have the and, the disjunctive or, the exclusive or, and the implication operator. So we'll start off with the simple one. We'll start off with the not. So if we have P, then not P, and under P we'll go ahead and do the different possibilities. The only two possibilities, true and false. Not P at that point, the opposite of true is false. And the negation of false is the opposite of false or true. Continuing on with the and operator, what basically we're gonna do is look at something like P and Q. So P, Q, and P and Q. We'll have four possible combinations at this truth table. So true, true, false, true, false. True and true, true and false, false and true, false and false. P and Q. True and true evaluates to true. True and false. Well, nothing can be true and false. So this is false. False and true, similarly resembling the true and false, is also false. And false, well, that's false. As you can see, the only true that the conjunction operator can produce is between two other true variables. The third operator that we're going to look at is or, such as P or Q. So because there's only two variables, we can actually use these two columns. And so true or true, and by the way, this is an inclusive or. So for example, if you said in order to be in this class, you have to either have calculus or discrete math. In inclusive or, it means you can have either calculus or discrete math or both. In an exclusive or, you can have calculus or discrete math, but not both. So those are the differences. So if we look at true or true, well, that evaluates to true. So either calculus or discrete math, if either one of those are true, that will evaluate to true. True and false, well, if you have one, not the other, that evaluates to true as well, right? Because you can still take the class. False and true, that evaluates to true. And the only time this evaluates to false is if both conditions are false. So if you don't have calculus and you don't have discrete math, then you cannot take the course. The next operator we're going to look at is the exclusive or. And with the exclusive or, as I mentioned earlier, only one condition needs to be satisfied. If you have both conditions satisfied, you will not be good. So in this case, although it's a little weird in English to say it, in order to take this course, you have to have either calculus or discrete math, but not both, which, I can't think of really a scenario where that would apply to you. But if you have a sentence like Pat is a man or Pat is a woman, Pat cannot be a man and a woman, so it's either one or the other exclusively. So let's look at what we get for the truth table. P exclusive or Q. So if we have true, exclusive, or true, this evaluates to false, because Pat cannot be both a man and a woman. Is Pat a man or Pat a woman? True, false, so that evaluates to true. Is Pat a man? No. Is Pat a woman? True. So that's true. Is Pat a man? No. Is Pat a woman? No. So that evaluates to false. The next one we're going to look at is the implication. So for example, P implies Q. An implication symbol denotes an if-then statement. So for example, the best example that I can think of is a politician saying something like, if I'm elected, then I will lower taxes. So let's look at that statement and let's see if we can figure out the truth values for P implies Q. True implies true. If I'm elected, okay, let's say that's a true condition, then I will lower taxes. That is also a true condition. So true implies true. Well, that's true. Now, the implication, what we're really worried about is the conclusion. Did he lower the taxes? Now, if I'm elected, then I will not lower the taxes, or I'll try to lower the taxes, but I failed. Well, the conclusion is false. Even though the hypothesis is true, he didn't really do his job, his promise, so that's the only time we're going to be really mad. Now, let's say the politician wasn't elected, but he was still able to lower taxes. We're still happy, so the conclusion is true. So false implies true is actually true. Now, if the person is not elected, then he or she will not lower the taxes. Well, guess what? That is actually true, because if he's elected, then he'll lower taxes. Otherwise, if he's not elected, he won't lower taxes. So that turns out to true. So if we're looking at this one, everything is true other than when the hypothesis is true and the conclusion is false. I hope this makes sense to you guys, and look out for more tutorials.